Now, tonight's story is a beautiful one. How galaxies, those sprawling cities of stars, are born from darkness and dust. I do hope it's not so interesting that it keeps you awake, but if it does, well, at least you'll know a bit more about the early universe before your morning coffee. So settle in, let your shoulders drop. Breathe slowly. You're about to drift through 13.8 billion years of cosmic history. No rush. The stars will wait for you. Let's begin. 13.8 billion years ago, the universe was small. Not just small in the way you'd describe a studio apartment with no windows, but unimaginably compact, hotter than a star's core and denser than a physicist's calendar during Nobel season. And then, in a moment that defies full comprehension, it began. Not with an explosion exactly. Despite the name, the Big Bang was more of a rapid, graceful swelling. Space itself expanded outward in every direction, faster than the speed of light, like a balloon being inflated with a leaf blower set to cosmic. There wasn't debris flying through empty space. Space was the debris, and it was making itself as it went. In those first fleeting microseconds, the universe was a seething broth of fundamental particles. Quarks jostled with gluons, photons zipped around like restless toddlers, and gravity, ever the patient sculptor, quietly began making notes. It was chaotic, blindingly hot, and extremely uncomfortable. Not a place for stargazing or marshmallow roasting just yet. But this early universe, for all its mayhem, was full of potential. Hydrogen and helium, the simplest, lightest elements, formed like cosmic Lego bricks, snapping together from the charged chaos. These humble atoms would go on to build everything: stars, planets, people, pet lizards, and of course, galaxies. About 380,000 years after the Big Bang, a mere blink in cosmic terms, something truly beautiful happened. The universe cooled enough for those atoms to capture electrons, forming the first neutral atoms. Light, which had previously been ricocheting around like a trapped firefly in a jar, was suddenly free to travel. This moment, known as recombination, created the cosmic microwave background, a soft afterglow of the Big Bang that still hums through the universe today. If your eyes could see microwaves, the entire sky would glow with the light of that ancient fire. But despite the glow, there were no stars, no galaxies. Not yet. The universe at this point was a dark, expanding cloud of gas and potential. If you could drift through it, you'd see nothing but subtle ripples, tiny irregularities in the otherwise smooth distribution of matter. These ripples were everything. They were whispers of quantum fluctuations from the earliest moments, stretched across the cosmos by inflation. Some regions were just ever so slightly denser than others, barely a difference really, but gravity noticed. And gravity does not forget. Over time, those denser pockets of hydrogen and helium began to pull in more and more material. Slowly, gently, they gathered like cosmic dew forming on a spider web. These clumps, the seeds of future galaxies, were utterly invisible to the naked eye, if eyes had existed, but they were already setting the stage for all the dazzling drama to come. It's a bit strange to think of the universe as quiet, but in a way, this era was. No light from stars, no glowing galaxies, just the faint murmur of matter falling into itself. It was a time of stillness before the storm, a long breath in before the universe exhaled starlight. And yet, even now, with all our telescopes and equations, we're still piecing together how it all unfolded. How did these minute fluctuations lead to the sprawling grandeur of spiral galaxies? Why did some parts of the universe become bustling hubs of stars, while others remained vast, dark voids? The answers are written across the cosmos, in every glowing nebula and ancient star cluster. We just have to keep listening. And so, the universe grew. Dark matter, the invisible framework of reality, began to tug and shape the forming structure. Hydrogen pulled into filaments. Gravity whispered, and the cosmos obeyed. Soon, the first stars would flare into life. The darkness would end, but for now, the stage was set. The universe was no longer just expanding, it was beginning to become. The stars hadn't arrived yet. The galaxies still slept. And for a few 100 million years, the universe remained cloaked in what we now call the cosmic dark ages. Despite the ominous name, there were no knights or castles here, no dragons, unless you count the kind made of plasma and hydrogen. This was darkness in the purest sense, a universe full of matter, but not yet light. After the Big Bang's brilliant opening act and the soft glow of the cosmic microwave background, things settled into a hush. Neutral hydrogen gas filled space like a vast, invisible fog. There were no stars to shine through it, no galaxies to twinkle in the distance. The universe had gone dim, not because it lacked energy, but because it hadn't yet figured out how to turn the lights on. Imagine floating through this time, an infinite, expanding sea of cool hydrogen and helium, the occasional electron drifting by like a lazy jellyfish. There's gravity pulling ever so gently on the gas, forming clouds here and there, but everything moves at a glacial pace. Not that time meant much. No clocks, no days, no sunrises, just the slow, patient accumulation of mass in a universe not yet in a hurry. Yet something extraordinary was quietly unfolding. In this shadowy silence, the groundwork for everything we know was being laid. You see, during inflation, the lightning-fast expansion right after the Big Bang, tiny quantum fluctuations were stretched across space. These little wiggles in density weren't much to look at, but over time, gravity took notice. Where matter was a tiny bit denser, it began to draw more of itself in. Over hundreds of millions of years, these ripples grew into tendrils and knots, what we now call the cosmic web. Think of the universe as a vast sponge, or maybe a three-dimensional spider web, strung together by filaments of dark matter and gas. These filaments are where galaxies would eventually form, pulled into place by the persistent hand of gravity. The empty spaces in between, voids, giant lonely stretches of near-nothingness, where almost no stars will ever shine. At the center of it all was a silent partner, dark matter. It doesn't glow, it doesn't reflect, and it doesn't interact with light at all, which makes it famously hard to study and somewhat bad at parties. But dark matter was absolutely essential. Its gravitational influence shaped the scaffolding of the cosmos, pulling ordinary matter, the hydrogen and helium gas, into place like the hidden frame beneath a painting. Without dark matter, the universe might have stayed a foggy cloud forever. Now, if you're still awake, and if you are, I admire your dedication, you might be wondering, why did it take so long for the first stars to appear? Well, building a star isn't as easy as throwing gas into a blender and flipping the sun switch. Hydrogen had to fall into dense enough pockets for gravity to take over, compressing it until temperatures rose to millions of degrees. Only then could fusion begin, the nuclear dance that lights up a star. But the early universe wasn't in a rush. It allowed gravity to work at its own pace, coaxing the gas into denser and denser clouds. Slowly, patiently, these clouds collapsed under their own weight. Somewhere in one of those dense knots of matter, the first spark would ignite. A single point of light in an ocean of dark. And when that happened, everything changed. But here, during this long interlude of silence, the universe was still gathering its breath. Like an orchestra tuning before the first note, the elements were in place, but the music had yet to begin. No galaxies, no stars, just a growing tension, a sense that something beautiful was about to happen. And perhaps that's the most comforting thing about this period. Even in the darkness, the universe was never truly still. Beneath the silence, it was dreaming, organizing, becoming ready. The light was coming, and then it happened. Somewhere, deep in a collapsing cloud of hydrogen and helium, gravity tightened its grip. At the center of that dense, invisible swirl, pressure soared, and temperatures climbed to millions of degrees. Atoms were pushed so close together that their very nature began to change. And in that moment, almost certainly unnoticed, unceremonious, a star was born. The first light since the Big Bang. These were no ordinary stars. Known as population 3 stars, they were unlike anything we see today. Enormous, unstable, and incredibly hot, they formed in the purest conditions the universe has ever known. There were no heavy elements, no carbon, oxygen, or iron, just hydrogen, helium, and a bit of lithium, all remnants from the Big Bang. This made the stars burn hotter and faster than the ones we're familiar with now. Some may have been hundreds of times more massive than our Sun, living short, furious lives before collapsing into black holes or exploding in brilliant supernovae. If you were floating nearby, though let's be honest, you'd be very, very crispy. You'd see these first stars lighting up their surroundings like bonfires in a vast cosmic forest. One by one, their light pierced the ancient fog of hydrogen that had filled the universe since the beginning. Slowly, the darkness began to lift. This period is called cosmic rionization, and while it sounds like something a sci-fi villain might attempt with a ray gun, it was a peaceful, albeit dramatic process. The ultraviolet light from those newborn stars began stripping electrons from the neutral hydrogen around them, ionizing it and making the universe transparent again. It was as though someone had cracked open the shutters of a cosmic greenhouse and let the light flood in. From our perspective, billions of years later, we can't see these first stars directly. They were too brief, too distant, and their light too faint. But their fingerprints are everywhere. They transformed the universe, from cold and dark to warm and glowing. They seeded the cosmos with the first heavy elements, the building blocks of everything more complicated than hydrogen, including you, me, and the cup of tea you might be sipping right now. In a way, these stars were the universe's first artists, sketching the outlines of galaxies on the blank canvas of space. But galaxies still hadn't formed. Not quite. These early stars were often scattered in small clusters, bound together by gravity, but not yet forming the grand, swirling cities of stars we see in the night sky today. These were more like villages, proto-galaxies perhaps, testing the waters of structure and cohesion. Yet the ingredients were coming together. As these massive stars ended their lives in violent supernovae, they blasted heavier elements into the surrounding gas clouds. Those enriched clouds cooled more efficiently, collapsed faster, and formed stars with greater ease. The next generation of stars, population 2, began to appear, a bit smaller, a bit more stable, and already more familiar. And thus the great cosmic cycle began. Gravity pulls in gas, stars are born, they shine, die, and scatter their enriched contents, allowing even more stars to form. Each generation builds upon the ashes of the last, layering complexity like stardust sediment. You might wonder, how do we know all this happened if we've never seen these ancient stars? The answer is hidden in patterns of light, like ghostly fingerprints left on the cosmic window pane. By studying the oldest galaxies, the chemical signatures in ancient stars, and the faint glow of the cosmic microwave background, astronomers can piece together the universe's childhood in astonishing detail. It's a bit like reconstructing the history of a forest by examining its oldest trees, its soil, and the direction of the wind. The clues are subtle, but they're there. And recently, we've begun to catch glimpses. With telescopes like James Webb, we're finally starting to see some of the earliest galaxies taking shape. Small, chaotic, glowing clumps of stars from just a few 100 million years after the Big Bang. We're peering into the nursery where the first light bloomed. It's humbling, really. These stars lived and died before our solar system was even a dream. Their light traveled across space for billions of years, past colliding galaxies, past wandering black holes, past the growing Milky Way, until it landed, softly, on the mirror of a telescope pointed at the sky. And now it rests in your mind, in the quiet of your evening, as you drift towards sleep. The universe, once dark and quiet, had lit its first lanterns. The night had ended, and the age of galaxies was about to begin. The universe was glowing now. Not brilliantly, more like the first hint of dawn on a cold morning. The stars had arrived, their light unraveling the fog, warming the silence. But they were scattered, isolated, flickering across the dark like distant campfires with no cities, no roads, just lonely pockets of light suspended in the void. But gravity had other plans. Those scattered stars weren't just floating randomly, they were being drawn together by invisible threads. Everywhere you looked, or would have looked if you'd had a way to see in ultraviolet and the patience of a cosmic being, small clumps of stars were converging. Gravity was quietly threading them into larger, more complex structures. The villages were becoming towns. The towns would become cities. And these cities, these proto-galaxies, were the first drafts of what we now call galaxies. It didn't happen neatly. There were no blueprints, no cosmic engineers marking out spiral arms with rulers. It was messy. Clumps collided, merged, ripped each other apart, and merged again. The early universe was a rough neighborhood. Gas clouds crashed into each other. Stars were flung from one group into another. Some early galaxies formed quickly, growing fat on nearby gas and gobbling up their neighbors. Others stalled, stranded in quiet corners of space like cosmic wallflowers. At this stage, galaxies didn't look like the elegant spirals or massive ellipticals we see in glossy telescope images. They were irregular, chaotic, unrefined, more like space blobs than the symmetrical beauties you might imagine. And yet, even in their chaos, they were growing. Slowly their shapes began to stabilize, nudged by gravity and sculpted by their environments. Much of this early architecture was influenced by a structure on an even larger scale, the cosmic web. You can picture it like a vast, three-dimensional lace of matter woven across the universe. Dense knots, where filaments of dark matter intersected, became the hubs, regions where galaxies would cluster, like seeds finding the richest soil. Long tendrils stretched between them, pulling galaxies along invisible rails of gravity. And in between these threads, vast voids, eerie and silent, where few galaxies would ever form. It's in these dense intersections that proto-galaxies had the most to gain and the most to fear. When you have a lot of gas and gravity in one place, things tend to get a little dramatic. Galaxies would crash into one another, a slow-motion dance that could take hundreds of millions of years. These weren't violent collisions in the way you might expect. Stars themselves are so far apart that most didn't hit anything at all, but their gravitational fields did tangle. Tidal forces twisted galaxies into strange shapes. Streams of stars were pulled like taffy, trailing behind their original homes. Gas clouds collided, compressing violently and sparking new waves of star formation, what astronomers romantically call starbursts. So amid the chaos, new stars bloomed, new clusters formed, and over time, what was once a shapeless clump began to resemble something more familiar. What determined the final shape of a galaxy? That's still an ongoing question, but we do know a few things. Galaxies that stayed relatively undisturbed with just the right amount of spin could flatten into elegant spirals, like our own Milky Way. Others, buffeted by collisions or formed in more crowded environments, turned into ellipticals, round, puffy collections of older stars. And some just never settled down at all, forever lopsided and patchy. We call those irregular galaxies, and frankly, we love them for their chaotic energy. But even in their irregularity, galaxies had become something new, something lasting. They were star forges, places where gravity and gas came together to ignite creation. Inside, stars were born, lived, and died, scattering their ashes, carbon, oxygen, iron, into the interstellar medium, enriching the galaxy for the next generation. Over billions of years, this recycling of stardust created planets, moons, atmospheres, and eventually, at least once, a small blue world where someone would one day whisper these stories into a microphone. It's easy to forget, looking at the night sky, just how long galaxies have been shaping themselves. The stars you see today are often second, third, or even fourth generation creations, made from the remains of long-dead ancestors. Galaxies are like family albums of the universe, each star a page, each cloud of gas, a new chapter waiting to be written. And as galaxies grew, they began to form communities, clusters, groups, superclusters. Just as stars gather into galaxies, galaxies themselves are not solitary. They orbit one another, influence one another, and in many cases, fall into each other's arms, gracefully, over eons. Our own Milky Way lives in such a group, a quiet corner called the local group, where it shares the sky with Andromeda, the Triangulum Galaxy, and dozens of smaller companions. But that's a story for later. For now, the universe had passed another milestone. It was no longer just a sea of gas and light. It was structured. It had complexity. It had neighborhoods. The stars had found homes, and the cosmos had begun to organize its brilliance. By now, the universe was far from empty. Galaxies had formed, some shy and compact, others sprawling and dramatic. Stars spun in enormous orbits. Gas clouds shimmered with newborn light. The darkness had not disappeared, but it had receded, drawn back like a cosmic curtain to reveal the grand stage of creation. And on that stage, galaxies had begun to find their form. Galaxies are not uniform. They come in many shapes and sizes, much like snowflakes. If snowflakes weighed a few 100 billion suns. Some spin elegantly, like pinwheels frozen in space. Others are squat and round, like celestial dumplings. And a few, bless their hearts, still look like someone tried to draw a galaxy from memory while riding a roller coaster. But how do these shapes arise? Why are some galaxies spiral, while others are elliptical or irregular? The answer, as always, lies in time, gravity, and a whole lot of cosmic patience. Let's start with the spirals, the show-offs of the galaxy world. Spiral galaxies are among the most beautiful structures in the universe. They're the ones you see on posters, desktop wallpapers, and science documentaries where violins play in the background. With their graceful curving arms and luminous cores, they look like cosmic hurricanes, caught mid-swirl. The Milky Way, our own galactic home, is a spiral galaxy. We live tucked into one of its arms, like a suburban speck on the edge of a great rotating city. Spirals tend to have lots of gas and dust, prime ingredients for star formation, so they're full of bright young stars lighting up their arms like festive fairy lights. The The structure of a spiral galaxy is all about motion. When a galaxy has a moderate amount of angular momentum, that is, when its gas and stars are rotating in a somewhat orderly way, it naturally flattens into a disk. Over time, density waves ripple through that disk, compressing gas and sparking star formation, and voila! Spiral arms appear. They're not rigid structures, but patterns moving through the galaxy, like traffic jams in space. The stars move in and out of them, but the arms persist. Of course, not all galaxies manage such elegance. Enter the elliptical galaxies, older, rounder, and generally a bit more relaxed. These galaxies don't have spiral arms. Instead, they're more like giant star clouds, shaped like spheres or stretched out rugby balls. They're usually composed of older, redder stars, with little gas left to make new ones. If spiral galaxies are bustling cities, elliptical galaxies are sleepy retirement communities, quiet, stable, and not big on change. Ellipticals likely form through galactic mergers. When two spirals crash into each other, especially if they're of similar size, their orderly motion is disrupted. The stars are flung into random orbits, the gas gets used up or blown away, and what's left settles into a big, shapeless mass. It's dramatic, chaotic, and oddly productive, like the cosmic version of smashing two snow globes together and letting the flakes settle. Then there are the irregular galaxies, which don't fit neatly into any category. They're the oddballs, the nonconformists. Some are young galaxies that haven't had time to form a shape. Others are older ones that got a bit too close to a larger neighbour and were pulled out of alignment, like a hat blown askew in the wind. Irregular galaxies might look like splatters or scribbles, but they're often bursting with new stars full of energy and potential. Some galaxies fall between categories: spirals with big bulges, ellipticals with rings, and other hybrid forms. Galaxy classification, like everything in astronomy, can be as messy as the universe itself. But we still try to put them in boxes, mainly because that's how humans like to make sense of things, even the stars. And of course, galaxy shape isn't just about beauty. It tells us something fundamental about a galaxy's history. A spiral galaxy likely had a calmer upbringing, steady gas inflow, maybe a few small mergers, but nothing too traumatic. An elliptical one probably saw battle, merging with other galaxies in a series of ancient cosmic collisions. Irregulars? Well, they might just be young or unlucky, or both. What's fascinating is that even now, galaxies continue to change shape. Spiral galaxies can become ellipticals. Small galaxies can merge and form giants. Gravitational interactions tug at their arms, twist their cores, and scatter their stars. Nothing in the universe is static, especially not something as dynamic as a galaxy. The Hubble Space Telescope gave us our clearest look at this cosmic diversity. With it, we've seen galaxies in all stages of life, from tiny proto-galaxies in the early universe to majestic spirals and massive ellipticals in the nearby cosmos. We've watched galaxies collide, seen them stretch and tear, and observed them rebuilding themselves in the aftermath. Every galaxy tells a story, and sometimes that story is written in the language of shape. So next time you see an image of a galaxy, a perfect spiral with blue arms, a glowing elliptical halo, or a messy clump of stars, know that you're looking at billions of years of history. A story of gravity and light, of stars born, aged, and gone, of gas clouds drifting, colliding, and becoming more than they were. Galaxies don't just shine, they remember. Let's come home for a moment. We've been drifting through the vast universe, tracing the birth of stars and the graceful formation of galaxies. But now, it's time to return to our corner of the cosmos. A place familiar, not because we've seen it from the outside, though we've tried, but because it's where every sunrise, every sigh, every human story has unfolded. We live inside a galaxy called the Milky Way, and she's quite the hostess. From our place within it, we can't actually see the Milky Way as a whole. It's a bit like trying to read the label from inside the bottle. What we do see is a glowing river of light stretched across the night sky, especially visible in remote places far from the glow of cities. That shimmering band, part dust, part starlight, is our view across the galactic plane. We're looking edge-on through billions of stars. The Milky Way is a spiral galaxy, and quite a large one at that. About 100,000 light-years across, it contains somewhere between 100 and 400 billion stars. Why the range? Because it's very hard to count stars when you're stuck inside the middle of them, looking out through dust clouds with a telescope and a lot of patience. But the best estimates place us at roughly 1/3 of the way from the center, out in the Orion Arm, like cosmic suburbanites. Not too close to the chaos, not too far from the action. The center of the Milky Way is a busy, energetic place. It houses a supermassive black hole named Sagittarius A, a gravitational heavyweight roughly 4 million times the mass of our Sun. It's not the brightest object. It doesn't devour as much as some other black holes, but it anchors the whole galaxy. Stars whirl around it in dizzying orbits, like moths circling an invisible flame. We know it's there not because we can see it directly, but because of how it affects its surroundings. Imagine watching stars move as if they're caught in an invisible whirlpool. Astronomers have tracked their paths for years, and the evidence is clear. Something incredibly massive, incredibly compact, and incredibly hungry is sitting at the galactic center. And no, it's not planning to eat the Earth anytime soon. The Milky Way didn't always look the way it does now. Like all galaxies, it has a long and occasionally turbulent past. It formed over billions of years, through mergers and acquisitions, in the corporate language of cosmology. Smaller galaxies were pulled in, digested, and folded into the spiral. Stars from these devoured galaxies still linger in the Milky Way's outer halo, orbiting on long, looping paths like wandering ghosts from long-lost homes. And it's still happening. Right now, even as you're listening, the Milky Way is pulling apart several smaller galaxies. The Sagittarius dwarf galaxy, for instance, is being slowly unraveled and absorbed. It's not a violent process, not on a human timescale, but over millions of years. It's like watching a drop of ink slowly swirl into a pool of water. Even more dramatically, the Milky Way is on a slow-motion collision course with our nearest large neighbor, the Andromeda Galaxy. Currently about 2.5 million light-years away, it's heading straight for us at roughly 110 kilometers per second. Don't worry, you have about 4 billion years to prepare. And when it happens, it won't be the end of the world. In fact, the two galaxies will likely merge into a new one, possibly an elliptical galaxy. Astronomers have even suggested a name, Milkomeda, which frankly sounds like a brand of space yogurt, but we'll let it slide. What's astonishing is that we can tell all of this from our vantage point inside the galaxy. Thanks to radio telescopes, infrared observations, and lots of clever math, we've been able to map the spiral arms, trace the star populations, and even simulate the galaxy's formation and fate. It's like piecing together a jigsaw puzzle from the inside and realizing the picture is much bigger than you ever imagined. And through it all, our tiny star, the Sun, just keeps orbiting. It takes the Sun about 225 million years to make one complete lap around the center of the Milky Way. That means we've only made about 20 trips around since the Sun formed. For reference, the last time we were in this galactic neighborhood the dinosaurs were just beginning to roam the Earth. Galactic years, it turns out, are not measured in birthdays, but in epochs. So here we are, spinning quietly in one of the galaxy's spiral arms, a pale blue dot circling an unremarkable yellow star, wrapped in the soft light of a billion suns. Every molecule in your body, every atom, was forged in stars that lived and died long ago, possibly in galaxies that were later folded into our own. You are, quite literally, part of the Milky Way's story, a moving, breathing fragment of galactic history, the product of star stuff, listening to starlight. The galaxy isn't just out there, you carry it within you. If galaxies are the great cities of the cosmos, then what built them? Who or what laid their invisible foundations, kept their stars spinning in place, and ensured they didn't drift apart like dandelion seeds in the wind? As it turns out, 3 unlikely architects have been quietly at work since the beginning: gravity, dark matter, and black holes. Not exactly a charming trio, perhaps. None of them glows or sings or gets invited to birthday parties. But without them, the universe would be a very empty, very formless place indeed. Let's start with gravity, the oldest and most familiar force of the bunch. Gravity is the great gatherer. It doesn't make a fuss. It doesn't shout. It simply pulls. Always has. Always will. In the early universe, when everything was expanding outward from the Big Bang, gravity was the reason things began to clump. It took those tiny ripples in the density of space, the faintest of wrinkles, and began to amplify them, drawing gas and dark matter together until stars and galaxies could form. It's slow, patient, and it never stops working. But here's the thing: gravity, while relentless, isn't particularly strong. It's actually the weakest of the 4 fundamental forces in physics. Drop a paperclip, and gravity will pull it to the floor. Hold a magnet above it, and suddenly the paperclip defies gravity with ease. That tiny magnetic field wins against an entire planet's gravitational pull. So why does gravity shape the cosmos? Because it always accumulates. It never cancels itself out like electric or magnetic forces can. The more mass you have, the more gravity you get. And in the vastness of space, where there are no friction brakes or air resistance, gravity's quiet persistence adds up. But even with gravity's help, there was a mystery. Something was missing. When astronomers looked at galaxies, really looked, measured how fast their stars were spinning, they found something strange. The outer stars, far from the galactic center, were moving far too fast. According to the visible mass of the galaxy, they should have been flung off into space like glitter from a spinning wheel. But they weren't. They were staying put. Loyal, orderly, stable. This was a problem. Unless there was more mass than we could see. A lot more. Enter dark matter. A substance we cannot see, cannot touch, cannot smell, and yet one we are almost certain exists, because its gravitational fingerprints are all over the universe. Dark matter doesn't interact with light, it doesn't glow. But it exerts gravity, and there's quite a bit of it, about 5 times more dark matter than normal matter by mass. That means for every visible star or gas cloud in a galaxy, there's a much larger, invisible halo of dark matter holding everything together. Imagine a galaxy as a glowing jellyfish swimming in a giant invisible bubble. That bubble, the dark matter halo, is what keeps the jellyfish from drifting apart. Without dark matter, galaxies as we know them couldn't exist. They wouldn't have formed in the first place. And if they somehow had, they wouldn't stay together. Stars would fly off in all directions, and the beautiful spiral arms we admire so much would never survive. So far, no one knows exactly what dark matter is. There are plenty of theories, exotic particles, supersymmetric partners, even ideas involving extra dimensions, but none confirmed. Still, its effects are undeniable. Like wind on the ocean, we don't need to see it directly to know it's there. Now, as if galaxies weren't already full of secrets, we come to the last of the trio: black holes. And not just any black holes, supermassive black holes. These monsters sit at the centers of nearly every large galaxy we've studied, including our own. They range in size from millions to billions of times the mass of the Sun. And while they have the reputation of being destructive, they're more like galactic administrators: quiet, mysterious, and extremely influential. We used to think supermassive black holes were just passengers, things that happen to form in the center of galaxies. But over the past few decades, we've realized they're more like co-authors of a galaxy's story. Their growth seems tied to the development of the galaxy around them. When they feed, devouring gas and dust, they release enormous amounts of energy, often more than the galaxy's stars combined. This energy can blow away the gas needed to form new stars, halting star formation for millions of years. In other words, black holes don't just sit there like cosmic drains. They regulate growth. They shape the fate of galaxies. This process, called feedback, is still being studied, but it's clear that supermassive black holes can influence their environments on colossal scales. Jets of plasma can stretch for thousands of light years, sculpting the interstellar medium and altering the flow of material across a galaxy. It's a bit ironic. The darkest things in the universe, the ones that swallow light and defy our gaze, are also the ones that hold it all together. Dark matter, gravity, black holes, the unsung architects of everything. And here we are, orbiting a star in a spiral galaxy, nestled in a dark matter halo, circling a supermassive black hole we'll never meet. Every step we take, every breath we draw, happens in a universe held together by invisible hands. So the next time you gaze up at the stars, remember this: the beauty you see is only half the story. The rest, the invisible scaffolding, the silent forces, the quiet gravity pulling it all together, is still there. Not shining, not speaking, but building. Always building. Galaxies may look serene in photos, graceful spirals, glowing halos, delicate dust lanes, but make no mistake, the universe is not a quiet place. Out there in the vastness, galaxies are constantly moving, drifting, orbiting, pulled by gravity like dancers in a never-ending waltz. And occasionally, those dancers get a little too close. Their arms entangle, their paths cross, and they collide. Not with a bang, but with a slow, spectacular ballet that unfolds over hundreds of millions, even billions of years. Yes, galaxies crash into each other. But before you imagine stars exploding and planets smashing like marbles, take a breath. The reality is more poetic. Despite their size, galaxies are mostly empty space. Stars are spaced so far apart that even in a full-blown galactic collision, the chance of two stars actually hitting each other is vanishingly small. It's like watching two fog banks pass through each other, only the fog is made of stars, gas, dust, and dark matter, all swirling in gravitational fields. But while individual stars may avoid direct collisions, the galaxies themselves do not emerge unchanged. When two galaxies meet, their gravity pulls and stretches them, distorting their shapes into long, flowing tendrils of stars. These are called tidal tails, and they can span hundreds of thousands of light years. They look like glowing ribbons unraveling into space, each one a trail of stars flung outward by the encounter. Gas clouds, on the other hand, are not so lucky. When they collide, they do so with gusto, compressing, heating, and often triggering a dramatic burst of star formation. These so-called starburst galaxies can produce stars at rates dozens or even hundreds of times faster than usual. It's a cosmic baby boom, sparked by the chaos of gravitational upheaval. Some of the most beautiful and chaotic galaxies we've observed are caught mid-collision. The antennae galaxies, for instance, two spirals in the process of merging, show long curling arms of stars and brilliant regions of new star formation. They're a snapshot of what happens when galaxies refuse to mind their personal space. And eventually, the two galaxies will settle into one. That final product often isn't a spiral anymore. Spiral structures are delicate, too easy to disrupt. After a major merger, the result is usually a large elliptical galaxy. The orderly orbits of stars are randomized, and the gas, much of it used up in the starburst or flung out into intergalactic space, is no longer plentiful enough to form beautiful new arms. This is how many of the largest galaxies in the universe came to be, not from peaceful accumulation, but from slow-motion crashes, like cities built by overlapping tectonic plates. But this isn't just ancient history. The Milky Way is not a passive observer in all this. It has its own collisions to reckon with. Right now, our galaxy is in the slow process of merging with several smaller dwarf galaxies. The Sagittarius dwarf galaxy is being pulled apart and absorbed, its stars now tracing ghostly loops through the Milky Way's halo. Other small galaxies are on similar paths, being digested, restructured, and folded into our own. And then there's Andromeda. Our nearest large neighbour, the Andromeda Galaxy, is on a collision course with the Milky Way. They're separated by 2.5 million light-years, but moving toward each other at about 110 kilometers per second. That might sound fast, but in galactic terms, it's a slow and graceful approach. The collision won't happen for another 4 billion years or so, but when it does, the result will be spectacular. What will happen to us? Surprisingly little, at least on the scale of our solar system. Again, stars are so far apart that direct collisions are unlikely, but the night sky will change. Over millions of years, Andromeda will grow larger and brighter, eventually dominating the view. The two galaxies will twist around each other, merge, and settle into a new shape, possibly a giant elliptical galaxy. Astronomers have lovingly nicknamed the future merger Milkomeda. Yes, really, scientific naming has its moments of whimsy. But even before that grand dance begins, collisions continue all around us. Galaxies in dense clusters are constantly interacting, their shapes distorted, their gas stirred. It's part of the life cycle of the universe. Galaxies are not static islands. They evolve, grow, and change through relationships, much like everything else in nature. What's especially fascinating is that these interactions aren't just destructive. In many cases, they're creative. Mergers can restart star formation, feed central black holes, and reshuffle the contents of galaxies in ways that lead to entirely new structures. Like pruning a tree or mixing two colors of paint, the result is something new, messy at first, but often more vibrant than before. And in this ever-evolving cosmos, collisions are not the exception, they are the rule. We tend to think of the universe as calm and unchanging, a kind of eternal night sky sprinkled with frozen stars. But it's alive. Galaxies are drifting, falling into each other, blending their light, their stars, and their stories. Even now, somewhere out there, two galaxies are beginning their long, slow dance. One day they'll collide, not in violence, but in union, and a new galaxy will be born, just as it always has been, just as it always will be. To gaze into space is to gaze into time. It's one of the quietest, most astonishing facts about the universe. Every star you see in the night sky, every galaxy captured by a telescope, is not showing you how it looks now, but how it looked then. Light, for all its remarkable speed, still takes time to travel. And space is vast, very, very vast. So when we look up at the stars, we are, quite literally, time traveling. Take the sun. The warm light touching your face during a late afternoon walk left the surface of the sun about 8 minutes ago. That starlight is already 8 minutes old by the time it arrives on Earth. You never see the sun as it is. You see it as it was. Move beyond our solar system and the time delay grows. The light from Alpha Centauri, the nearest star system to us, is over 4 years old. And the glow of the Andromeda Galaxy? That's ancient light. It began its journey toward us more than 2.5 million years ago, long before the first humans, long before written language, long before the wheel. That gentle shimmer in the sky is a memory, a whisper from a past so distant it predates everything we know. But we can go even further. With the right tools, we can peer back billions of years, almost to the beginning. The deeper we look, the further back in time we go. It's like peeling away the layers of cosmic history, one photon at a time. This is where telescopes become time machines. Take the Hubble Space Telescope, for instance. Launched in 1990 and orbiting high above Earth's atmosphere, Hubble has shown us things we never imagined we'd see. One of its most famous achievements is the Hubble Deep Field. A simple idea, really. Astronomers pointed Hubble at what seemed like a completely empty patch of sky, a part so dark and blank that it looked like nothing was there. They let it stare, for days. And when the images came back, that nothing became a sea of galaxies, thousands of them, each containing billions of stars, all packed into a dot of sky smaller than a grain of sand held at arm's length. Some of those galaxies were over 13 billion years old. We were looking back in time, almost to the moment when galaxies first began to form. That light had travelled for nearly the entire age of the universe just to reach us. It had crossed unimaginable distances, passed by uncountable wonders, and finally landed on Hubble's mirror, leaving behind a faint but permanent trace. Now we have an even more powerful time machine, the James Webb Space Telescope. Launched in 2021, Webb can see even deeper into the past. Not just because it's bigger, though it is with a mirror over 6 meters wide, but because it sees in infrared. That's key. As the universe expands, light from distant galaxies is stretched, like pulling taffy, shifting it to longer wavelengths. This process is called redshift, and it means that the earliest galaxies now shine mostly in infrared light. Hubble could glimpse some of that light. Webb was built to bathe in it. Already it's showing us galaxies that existed just a few 100 million years after the Big Bang. Some are small, irregular, and chaotic, just as we'd expect. Others are surprisingly mature, like fully grown cities appearing right after the first huts were built. These discoveries are reshaping our understanding of how fast galaxies formed, and maybe even rewriting parts of cosmic history. And here's the most poetic part. The farther away a galaxy is, the younger it is in reality. But the older it appears to us, because we're seeing it as it was billions of years ago. You might think then that we're always looking into the past, and that's true. But it's also how we learn. We can't rewind the universe, but we don't need to. It has already sent its memories to us, one photon at a time, and we are catching them slowly, quietly, with glass and gold and great patience. In a way, this is what science often is, listening to the past with better and better ears. Of course, all this looking back has its limits. There's a point in time we can't see beyond, the cosmic microwave background, the afterglow of the Big Bang. It's not that there's nothing before it, but that the universe was opaque. Before then, light simply couldn't travel freely. It was trapped, scattered, like fog in a dense forest. Only after the universe cooled and atoms formed did light finally break free and begin its long journey to us. That's our cosmic horizon, the edge of visibility. And beyond that, mystery, possibility, questions we're still trying to answer. For now, what we do have is extraordinary. Every image from Webb, every frame from Hubble, is a photograph of the past. A snapshot of a moment so distant it feels like fiction, but it's not, it's real. That light is real. It touched something once, a star, a galaxy, a cloud of gas, and now it touches you. So the next time you stare into the night sky, remember, you're not just looking up, you're looking back, way, way back. The stars are still shining, but many of them are shining from a time when Earth was young, when there were no eyes to see, no names to give them. And yet their light persisted, crossing space and time to find you here, now. The universe doesn't just tell stories, it remembers them. We've traveled far. From the first whispers of matter to the sprawling spirals and glowing cores of galaxies, we've watched the universe light up, organize, and evolve. And now, as we drift into the present, we find that the universe is far from finished. Galaxies are still forming, still merging, still reaching toward one another across the cosmic void. Because galaxies, like people, tend not to live alone. Instead, they gather. They form groups, clusters, and even superclusters, massive structures so vast they defy simple imagination. Our own Milky Way is part of one such gathering, the local group. It's a relatively quiet corner of the cosmos, made up of more than 50 galaxies, most of them small and faint, dwarf galaxies orbiting the larger ones like cosmic satellites. The local group's two largest members are, of course, us and our neighbour, the Andromeda Galaxy. We're the twin giants of this little galactic suburb, slowly spiralling toward each other. We've already spoken about our future merger, but for now, the two galaxies maintain a respectful distance, close enough to notice each other, far enough not to bump elbows just yet. Surrounding us are a host of smaller companions. Some, like the large and small Magellanic Clouds, are easily visible from the southern hemisphere and are themselves in the process of being drawn into our spiral arms. Others, like the Draco Dwarf or the Ursa Minor Dwarf, are more elusive, faint collections of stars barely hanging onto their identities as they orbit through our galaxy's dark matter halo. Groups like ours are common, but they're just the beginning. Zoom out and you find galaxy clusters, collections of hundreds or even thousands of galaxies bound together by gravity. The Virgo cluster, for example, sits just beyond our local group, and it's filled with spirals, ellipticals, and every shape in between. Here, galaxies aren't politely distant. They crowd together, interact, and often collide. In these environments, you can almost feel the tension, gravitational tug-of-wars happening across millions of light years. These clusters are embedded in even grander formations, superclusters. The Laniakea supercluster, our cosmic address in the largest sense, stretches over 500 million light-years across and contains about 100,000 galaxies. That's right, 100,000 galaxies, each with billions of stars, all drifting together through the cosmos, following the flow of gravity through a web we're only beginning to map. And even that is just a thread in the larger cosmic web. the vast structure that forms the skeleton of the universe. Galaxies are not sprinkled randomly through space. They form patterns, filaments, sheets and nodes, like a vast foam stretched across a dark sea. These structures, seeded in the earliest moments after the Big Bang, have been shaped over billions of years by the subtle nudging of dark matter and the persistent pull of gravity. In between these filaments lie voids, immense, empty regions where few galaxies exist. Some are tens of millions of light-years wide, dark and silent, with only the occasional lonely galaxy drifting through like a ship at sea. It's in this contrast between crowded clusters and vast voids that the structure of the modern universe reveals itself. But not everything is growing. Not everything is rushing forward. There are signs that the universe's grand dance may be slowing, not in motion, but in creativity. Many galaxies, especially the big, mature ellipticals, are no longer forming stars. They've used up or lost the gas needed for stellar birth. We call them red and dead, not because they're lifeless, but because their aging stars glow a soft reddish light and no new stars are replacing them. Even our own Milky Way is forming fewer stars than it once did. It's not done, not by a long shot, but the era of frantic starbirth is behind it. We're in a quieter, more reflective chapter of galactic life. And the universe itself, it's expanding faster and faster thanks to something we still don't fully understand: dark energy. This mysterious force is pushing galaxies away from each other at accelerating speeds. Over the next few trillion years, it's possible that galaxies not bound to us by gravity will vanish from view entirely, their light stretched until it can no longer reach us. The universe will grow colder, quieter, and more isolated. But don't worry, we've got time, a lot of time. For now, galaxies continue to interact, evolve, and surprise us. With telescopes like Hubble, James Webb, and those still to come, we're peering deeper into space and further back in time than ever before. We're catching the echoes of galactic birth, the ripples of collisions, the faint glimmer of newborn stars in galaxies so far away, their light left before Earth had oceans. Every night sky is filled with those echoes. Every glowing dot is a story. Some are just beginning, others ended long ago, but all of them are part of this vast, beautiful architecture, the visible universe still painting itself, even now. Galaxies are no longer just mysteries. They are companions, teachers, reminders, that even in a universe so large we cannot hold it in our minds, we belong to it, and it belongs to us. And now, after billions of years and billions of light years, we've come to the end of our journey. We've drifted from the birth of the universe to the birth of galaxies, from the dark ages to first light. We've watched stars flare into life, cluster into cities of fire, and spin through spirals shaped by invisible hands. We've seen galaxies collide, merge, fade, and grow old, quiet giants in a living cosmos that never stands still. We've journeyed through the Milky Way, our own galactic home, and felt the pull of black holes and dark matter, the quiet architects of all that we see. And we've looked back in time, really looked, catching ancient light that travelled across the entire universe just to meet us here, now. It's humbling, isn't it? To know that the stars above you are not just points of light, but memories. That galaxies are not still images, but stories still unfolding. And that everything around you, your hands, your breath, the thoughts floating through your head, was forged in the heart of a long-dead star. You are made of galaxy stuff. You are part of the story. And maybe, just maybe, that's why we find the night sky so comforting. why something inside us quiets when we look up, because some ancient part of us remembers what it feels like to drift through starlight. So now, as your eyes grow heavy and your thoughts soften, I'll ask again, just as I did when we began. Where in the world are you listening from tonight? And what time is it where you are? Drop a note in the comments if you'd like. I love hearing where these little journeys are taking root all across the globe. It reminds me how connected we are, by wonder, by curiosity, and by stardust. And if you enjoyed drifting through the cosmos with me tonight, consider leaving a like or subscribing for more sleepy science. There's a whole universe waiting for us, and I'd love to explore it with you. But for now, let's rest. Let the stars keep watch, and let the galaxies keep spinning just as they always have. Good night, fellow traveler. You're home among the stars.